Hey guys, welcome back to another video on the channel. In this video, we will learn about one of the most widely used subword tokenization algorithms, that is byte pair encoding or BPE. So by the end of this video, we will understand how BPE builds its vocabulary step by step using a simple example. So let's begin. So there are basically several algorithms used to create subword vocabularies, but the three most common ones are byte pair encoding, word piece, and unigram language model. All three have the same goal, that is to break words into smaller, meaningful pieces called subwords. However, the way they learn these subwords is different. In this video, we will focus on byte pair encoding, commonly known as BPE. So what exactly is BPE? So byte pair encoding is a subword tokenization algorithm that automatically learns common subwords from a large collection of text. So basically, instead of storing every possible word in its vocabulary, BPE starts with individual characters and gradually combines the most frequently occurring adjacent pairs. After many such merges, it builds a vocabulary containing useful subwords that can efficiently represent both common and unique words. This allows language models to keep their vocabulary compact while still handling words they have never seen before. So this is like the entire step-by-step pipeline of byte pair encoding algorithm. So basically, we first start with taking all the characters present in our corpus or vocabulary. Then we find the pair of characters or subverbs which occur together the highest number of times, and we merge them together. So this results in addition of a word in the vocabulary, and so the vocabulary gets updated. And so the number of elements in vocabulary, that is k, it increases. So if k reaches our predefined final size, then we stop this algorithm, and if no, then we continue going on and on. So let's see how this works with the help of a simple example. So here we have our training corpus, which consists of six words: low, lower, lowest, new, newer, and newest. Here this dash at the end represents space at the end of the word. So first we initialize our vocabulary, which has a size of 9. And we have already a predefined vocabulary size of k equal to 12. So basically, for this dummy example, we will only do 3 merges, and then our vocabulary will reach 12, where we will stop. So we first take the frequency of occurrence of all the subverbs or characters together in pair. So we can see that the character pair of W and E occurs the most number of times together, that is 4. So we merge these two together, as you can see in the updated vocabulary, and so our size becomes 10. Then we check if 10 is less than 12, which is yes in this case, then we continue the algorithm. So in the second step, after we merged L, W and E together, as you can see in the updated corpus, then we again look at which has the highest frequency. So we observe that L and O and W and N and E, all of them have a frequency of 3. Here we can randomly select one, or the one which occurs the first can be selected. It depends up to you. So in this case, we select L and O together and we merge them. This results in again an updated corpus, and the vocabulary size increases to 11. Then we have a check. As it's less than 12, we continue. And here you can see that after updating the corpus with L and O, we see that LO plus W, that is this pair of subword, has the highest frequency of 3. Again, N and E also have a frequency of 3, but it depends on which one you want to take. So here we have taken L, O and W together and updated the corpus. So now the vocabulary size increases to 12, and so here we stop our algorithm. And so this is our updated corpus. So on this basis, how do we tokenize the words? So as you can see, loop and followed by a space is that only because we have tokenized it in that way. And you can see all the other tokenizations followed by. So for example, in lower, we split it into LOW plus WU plus R space because this was our new corpus. And so on you can see throughout. So before ending, let's take a look at the key properties of byte pair encoding. So first is that it learns the frequency subwords. So the subwords which occur the most number of times together, it learns how to merge them and treat them as a single unit that creates reusable subwords. Secondly, it is able to handle rare words efficiently as in our word-based tokenization, whenever we used to see a word which is out of vocabulary, it would result in giving ang token. But here, if we see a new word, then there are chances that it could be split into familiar subwords, which the model already knows. So it helps in handling rare words. And thirdly, we have a fixed vocabulary size, which helps in tackling the issues between rare words and common words. And so the model reaches a balance between them. So these properties make byte pair encoding an efficient and practical tokenization algorithm, which is why it has been widely used in many language models. So that's going to be it for the video. Hope this video helped you understand how BPE works and how to build a subword vocabulary step by step. If you found this video helpful, make sure to like, comment, and subscribe, and let me know how I can improve my videos further.